All right, in today's lesson, we're going to learn the last bit of word problems, okay? And we're still going to use Desmos to solve them. So we're going to learn about exponential growth and exponential decay. You might have seen this in a science class. Don't ask me which one, but you might have seen it. So exponential growth, when a quantity increases, okay? All right, that's why it means growth at a fixed percent and increasing rate over time. Okay, so when you have something that's growing, so you're gonna look for the words like growth or increases or those words that just mean that it's going up, it's increasing. Okay, and then we have exponential decay. Exponential decay, well, that's when a quantity decreases at a fixed point. Okay, all right, so the formula. You have the same formula, but there's only one thing that changes when you go from exponential growth to exponential decay. Okay, so our formula is y equals a 1 plus, so this plus right here, we're going to come back to that, r to the t. If it is growth, okay, if it's growth, you will say 1 plus r. If it is decay, you will say 1 minus r. And your variables still mean the same thing, okay? And I wanted to write this in y equals because this relates to your exponential equation. But the y is just your final amount, okay? Let's change this a so we don't get all messed up with stuff, okay? I don't know why it does that. Let's change the A. Pull the keyboard out. There we go. Uh-oh. There we go. All right, we're going to change that to a P, just so we can stay consistent, okay? So it's not too crazy. So that P. So that P, it still means initial amount. All right, and your R is still your rate in decimal form, and T is time. But T here does not have to be years. T here is based off your rate. If your rate says that you're increasing by 5% per minute, then your T needs to be in minutes, okay? If I say that you're decreasing, you're losing people at a 50% rate per round, then your time is in rounds, okay? You have to look at your rate to figure out your time, okay? All right, so half the battle is just setting up the equation, okay? So let's figure out how to set these equations up, all right, by looking at keywords, okay? So the population of a small town is 4,000 and is growing. That means I'm going to use plus at a rate of 3% per year. So that means my year is in time. Okay, and it says the population is 4,000 people. Now, A says write an exponential function to represent this data. Okay, so we're going to write an exponential function only knowing these three things. And that's fine because we're not solving anything. We're just writing an equation. So, y is my final amount. Do I know my final amount of population? No, I don't. So we're going to leave it as y. P is your initial amount. Do you know how much the population started with? Yep, 4,000. I'm growing, so it's a plus. Your rate's right here. That 3% goes 1, 2. So it's 0.03. And I don't know my time. I know my time is in years, but I don't know my time, so I leave it as t. And there's your equation. Now, I can simplify this inside, can I not? So it's me y equals 4,000. We're simplifying, 1.03 to the t. Now, I want to tell you, when you simplify, if inside the parentheses is greater than 1, it is growth. If inside the parentheses is less than 1, then it is a decay. You're going to need that know that for your test, okay? If inside the parentheses is greater than 1, it is growth. If it's less than 1, it is decay. So we go to the next, to B, and it says, what will the population be in the town after 10 years? Well, 10 years is my T, right? I've already made the equation. I just have to replace t with 10. So we're going to say y equals 4,000, 1.03 to the 10. And we're going to type this into Desmos. So I've got it typed into Desmos, and my answer will be after 10 years. Now it's people. People you can't round up. You can't round that 6 to a p. Okay, now if Delta Math or something like that tells you to round up, then round up. But logically speaking, you can't round a person up. So it's just going to be 5375. Okay? So y will equal 5375. Okay? All right, let's go on to the next one. So it says James purchased a truck at $29,500. The value of the truck depreciates by 12% per year. Well, if I'm depreciating, that means I'm decaying. So that means I'm no longer growth, I'm decay. Okay? So it wants us to write an exponential function. So write what you know, what we highlighted. So that 29,000 is your P. Depreciate means I'm going to say 1 minus. My R is 12%. Move that decimal 2 places. So it's going to be 0.12. And my time's in years, but I don't know my time. Simplify it. So my final answer will be y equals 29,500. That's going to be 0.88 to the t. Do you see how that's less than 1 and it's the depreciation, so it's the decay? Okay, so less than 1 is decay, greater than 1 is growth. All right? Now, the next problem says, what will the value be of the truck after 8 years? So I'm going to plug my 8 into t. And it's going to be y equals 29,500, 1.88 to the 8 years. So we're going to plug it into Desmos to get our answer. Okay, now we're talking about money, so we can round 2 decimal places, okay? So 29,500, so we're going to say y equals 29,500 times 0.88 to the 8th power. So it's going to be 10,609.22. See, that 8 makes that one a 2. 10,609.22. 10,609.22. That's how much the truck will cost. And depreciated, so if you notice, my P got smaller. Okay, that's what you want. All right. Next one, a computer engineer creates a software program worth $28,000. Okay. The program depreciates at, let me erase that, at 35% each year. How much money will the program be worth in 4 years? Okay, let's solve this. All right, let's go ahead and solve this. Okay, so it is saying a computer is worth. So that means right now it is $28,000. He creates it. That's initial. When you create something, that's the beginning. So it's going to be 28,000 is going to be my P. I'm depreciating, so it's 1 minus. My rate is 35%. We're going to move that decimal 2 places, so now it's 0.35. My time is in years, so where's my years? It's 4. And I'm missing my y. So we're going to plug this in. You can simplify it if you want to. And we'd have y equals 28,000. Yeah. 1 minus 0.35 is going to be 0.65 to the 4. Okay. Type it in. And I get 4998.18 because that 5 rounds that 7 up. So 4998. So 4998.18. So 4998.18 is what it's going to be worth. Okay? All right. Let's keep going. We're going to do 1. It's locking up. 2. All right. We're going to do the rest of these. Okay. So in 1981, the humane, and we're just going to say HIV was discovered, okay? That's what y'all know it as. In 1987, it estimated that 50,280 people in the United States were diagnosed with the infection. In 2000, that number grew. You hear that word grow? Grew. That means it's going to be a growth problem, okay? It grew to 264,405 people within the United States. Given this information, find the rate of growth for the infection. So it wants me to find the rate, so that means I'm missing my rate, okay? Now, it says that in 1987, when it started, there was this many people. It grew to that. Now, this one's a little bit different, okay? So, my final amount is the 264 because it grew to that. Okay. It started with the 50,000. I don't know my rate, but I know it's a rate of growth. I don't have my t, but you can't be missing more than two variables when you're solving for a variable. But let's think about it. It started in 1987 and it went to 2000. How many years has passed between 2000 and 1987? 13 years. So my t would be 13. Okay, 13 years have passed. So that's going to be my time. So sometimes they're going to give you the dates and you have to calculate your time. Okay? All right. So now that I have all that information, now this is a line 1, line 2 situation. Line 1, line 2. Okay? So we're going to have to, when we type this in, 2 separate lines. Okay? We have been doing just the plugging it in because we didn't know what y is. But now we know what y is, and we're going to have to do the line 2, line 1. Okay? All right. So line 1 is going to be y equals 264405. Oh, I forgot my 2. And then it won't let me type the 2. There we go. Second one is going to be y equals 5280, parentheses, 1 plus, it's r, but we're going to say x, and I'm raising it to the 13th power. So I need to see where these two lines intersect, so I'm going to zoom out. I'm going to zoom out. I'm going to scroll. We got to get pretty far up, guys. Which is fine because Desmos calculates it for you. There we go. Zoom in a little. Okay, click the line. So there's my gray dot. Okay. Now, we don't want the negative one. So we need to zoom in some. Okay, keep zooming in. All right, and there it is. Okay, I typed my equation in wrong. So my answer is 0.1362, but it's a percent. Percent's 2 decimal places, right? So that 6 going to round that 3 to a 4, and it's going to be 14%. Okay, so my R is 0.14 or 14%. Okay, all right. Let's do another one. All right, so between 1988 and 1992, the number of HIV patients who died from HIV-related causes was this many. In 2000, the number of related deaths decreased to this many. Find the rate of decay for the number of deaths caused between these two dates. Well, again, it didn't give me the time, but it gave me the 2 dates. So I need to know how many years passed between 1988. Forgot I can't write off of this. 1988 to 2000. Well, that was 12 years, right? So 12 years have passed. So it decreased to this. So that's your final amount. It started with this. I decreased, so 1 minus r, and 12 years have passed. Okay? So now I'm going to find the intersection between these 2 points. Okay? So y equals 59807. And then y equals 181,212. 1 minus r, which is x. Raise it to the 12th power. I'm going to go home just because I scrolled out a lot. Okay, so now let's zoom out. Okay, scroll down, scroll, zoom. I do a mixture of scrolling and zooming. There we go. Okay, zoom back in. All right. Now, which one do we want? Okay, you got to figure out which one we want. You want the smaller one because your rate can't be over 1. Okay, we don't want a rate over 1. All right, so answer is, so when I move this one, it's going to be 9%. Okay. All right, so let's move on past rate. So that's solving for your R's, if it'll let me scroll. Here we go. All right, so let's do a couple like this, okay? So it says, how long will it take $30,000 to accumulate to $110,000 in a trust that earns 10% annual interest? All right, when it says annual interest, that's just growth, okay? Now, if it was daily interest or weekly interest, you would have to use your compound interest formula, okay? All right. So, but you could use your compound interest formula for this if you just want to remember money goes with compound interest and everything else goes with growth and decay. Okay, it'd give you the same thing. Annual will just make your N1. All right, so I need to figure out what these are. So how long will it take 30,000 to accumulate to that? So I'm going to go from this to that. So that means this is my starting and this is my final. Okay, 10% is just 0.10 for your R. Okay, and I'm missing my T. So we're going to say this is equal to 30,000. It's growing because we want the money to grow, so it's growing, plus 0.10 to the T. Line 1, line 2, solve for that T. Okay, all right, so let's pull up Desmos. So I've got y equals 1, zeros, and then line 2, y equals, make sure I type all those zeros in right, and then it's 1 plus 0.10, and I raise it to the T, but we're going to say x. I'm going to go, well, no, I don't need to go home because I got to go higher. So we're going to zoom out some more. Okay, keep zooming out, keep zooming out. Keep zooming and scrolling. Keep zooming and scrolling. Zooming. There we go. All right, we found the answer. Click that point. So it's going to take about 14 years is what you'll say. Okay, so T is going to be 14 years. All right. All right. So now let's do one more and call it quits. And if you need more examples, just let me know. All right, so the next one, let's highlight what we need, okay? So how long does it take to double $1,000 annual interest rate at this rate? Now, if I want to double something, that just means to multiply it by 2. So if I start with 1,000, that means I want to end with 2,000. If it told me to triple, I would have multiplied it by 3 and got 3,000, okay? So you'll see those though, so be careful with them. This decimal, move it 2 places this way, so it's going to be 0.0635. And I don't know how long, so we're going to put T up there. All right, so we're going to type this into Desmos, left-hand side line 1, right-hand side line 2. So we go up here, and I'm going to say y equals 2,000. Y equals 1,000, and then it's 1 plus 0.0635, raise it to the x, find their intersection. I am going to go home on this one because we need to go back down to 2,000. So, zoom, 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 scroll, there we go, look right there. So it's going to take about 11 years for it to double. Okay? All right, so I hope that helps you with today's work. Let me know if you need more examples or more videos.